All right, good afternoon, everybody. For tomorrow, quiz 3 covers everything through chapter 7, looping. Today we're going to be talking about the logical operators. Specifically, we're going to be talking about the logical AND and the logical OR. So there is the logical AND, which is the way to connect two conditions together. And then
Logical, what's that?
the logical OR, two pipes. I'm sure you all have seen this before. If I have two conditions, A and B, I have two conditions, A and B. A is true, B is true, therefore A and B is true. A is true, B is false. A is false, B is true. And they're both false. And then for the logical OR, so if I have A or B, if they're both true, A or B is true. If A is true and B is false, the results are true. A is false, B is true. A is false, B is false. False. Okay. So this will allow us to connect two conditions together. Many of you were already trying to do that in our Buford scale application. Oh yes, wind speed again. That's right, yes. So wind speed of 34 represents a fresh breeze.
Not really.
Well, regardless of your subjective feelings about it. Okay, so the way this is accomplished is through the use of this connector of the two ampersands here. So for instance, if I have wind speed is greater than 0 and wind speed has to be less than or equal to 6. Okay? So for this if statement to resolve to true, both of these two conditions need to hold. Then I have an else if. If wind speed is greater than or equal to 7 and wind speed is less than or equal to 12, then it's a light breeze. And we continue to do this all the way down until we hit that else. Okay, so if the wind speed is greater than 50, it's beyond a strong breeze. Otherwise, we've got an input error. Something went wrong. The user input something incorrect. Okay. Any questions over how to use the logical operator to connect two conditions together? You're right. We wrote this using just one condition because we had 0 as the baseline. So we could always compare it against 0 and against the previous condition. So in order for this to make sense, you would have to have a situation where you don't have 0 as the baseline. Here is the light scale. Okay, this is measured in microns. We're going to classify visible light depending upon its wavelength. In this particular situation, we don't have a 0 to compare against. So we have to go, it has to be between 0.4 microns up to 0.423 microns, or in between this range here. What I would like you to do is I would like you to write a program that's going to classify this. And additionally, you're going to concern yourself with a dumb user. Okay, so if a user enters in microns that goes beyond the visible light scale. So for instance, let's say they type in 12 microns, which is beyond the visible scale. You should output an error message indicating to them that it's an invalid number, and it must be a number between 0.712 and 0.440. Okay, so let's say, for instance, I enter in 0.445, which should be okay. So it will print out the wavelength and what color that corresponds to. Okay, so your program needs to worry about a dumb user. So what kinds of mistakes could a user do here? Yeah, non-numeric data. So they could type in something like this. You need to give an error message, or if they go beyond the bounds of what the program will allow, you need to print out an error message. So if you listened very carefully, you heard me say either it is not a number, or it is greater than the top end of this screen, or it is smaller than the bottom end of this scale. Okay? So that should give you a hint on how to do this particular piece. Okay? If you look on Moodle, this light scale is posted up there, so you can use that to do your classifications. Any questions over what I'd like you to do today? All right, good. Go ahead and get started.